Thanks for watching this video. Today I'm going to talk our work SEMA, which is a text simplification evaluation through semantic alignment. Today I'd like to introduce our works from these 5 aspects. Text simplification is a rewriting operation that aims to improve the comprehensibility of the text by modifying, deleting, simplifying text. It tries to retain the main semantics of original text while improving readability of the text. As related researches are in the early stage, the result of TS cannot meet the needs of the audience well. One of the difficulties is the lack of reasonable TS evaluation indicators. It should be evaluated from 3 aspects: fluency, simplicity, and correctness. Our work revolves around the last aspect. We collected the corpus used for the experiment, which is generated by manual rewriting to varying degrees. The simplified English corpus comes from an English website. Each article is written in 3 levels, and level 1 is the simplest. We collected 200 English passages and 100 English sentences. Each piece includes 3 levels. We manually judge the semantic retention of level 1 and level 2 are 50% and 70% respectively. The Chinese corpus comes from the text of the Chinese news reading textbook and its original text. We collected 100 sentences, and the semantic retention of the adapted text is around 80%. The result we expect to achieve is that the evaluation of semantic retention result of SEMA is similar to the result of manual discrimination. In recent years, the evaluation indicators of machine translation have been increasingly used in the evaluation of TS, including BLU root based on n-gram and WERTR based on edit distance. In machine translation tasks, BLU is the most widely used evaluation indicators. It has low computational cost, so it is widely used. SERA is an evaluation indicator based on reference sentences. It focuses on the aspect of words added, deleted, and retained, but it cannot evaluate sentences at semantic level. SEMAC is a semantic structure-based evaluation indicator proposed in 2018, but it relies too much on string matching in the judgment of semantic consistency. SEMAC uses 2 outside tools, UCC and word alignment. UCC aims to extract the scene graph formed by main relation and participants to represent the main semantic information in the text. The scenes of UCC represent motions, actions, or states that persist in time and are divided into state and process. A state represents a continuous state in time, such as the sentence "There has been conflict in Syria for the last 9 years." A process describes an event that is evolving and unfolding in time, such as the sentence "The dog runs into the house." Each scene contains a main relation, one or more participants, such as John kicked his ball. In this scene, the participants are John and his ball. The relation is kicked. For units that cannot form a scene, the UCC sets a category C to represent the subunit of a non-scene unit. Modifiers are marked as E. For example, in the non-scene unit, his ball, his is E and ball is C. Word alignment is a tool which can align the same words in two sentences. In SEMA, UCC decomposes each import sentence into a set of sentences. Word alignment aligns the words of the import sentence with one or zero words of the output sentence to form a set A. Here, the input sentence is the original text and the output sentence is the simplified text. The goal is to evaluate whether the main meaning of input sentence are kept in the output sentence. The formula is as follows, and the n-in and n-out are the number of sentences of input and the number of sentences of output. I will use an example to explain. In the output sentence is the last Wednesday, the United Nations Commission of Inquiry sent out a 121-page report. The output sentence is the UN writes a 21-page report. The relationship of impulsion is centered and the participants are United Nations Commission of Inquiry and report. Then match with the output sentence, use the word alignment set A. In this example, all the core sematics are matched, so the semantic retention is very high. The experimental results on English sentences are as follows. It can be seen that the results of level 1 and level 2 are not suitable with human judgment. Based on the characteristics of SEMA, we propose a TS evaluation indicator SEMA based on semantic alignment. Semantic alignment includes complete alignment, partial alignment, and hyphonymy alignment. Complete alignment is to remove the penalty coefficient and n-in less than n-out conditions of SEMA. In the actual corpus, in order to understand easily, many sentences are often rewritten into multiple sentences, so the penalty coefficient and the penalty conditions are unreasonable. Partial alignment. SEMA requires that the smallest unit of the participant in the scene match the word of the output sentence. For the case where a participant contains multiple smallest units, SEMA requires that all the smallest units should be matched to get score 1, otherwise it is 0. For example, for the input sentence, I like banana, apple, and orange, the participants are banana, apple, orange. When the output sentence is I like apple, only apple is matched in the smallest unit of the participant, but the value is 0. Partial alignment calculates the matching degree of every single smallest unit. There are many hypotheses in our corpus, but the SEMA cannot identify, so based on one night, the alignment of hypotheses are added. It can be seen that at each step of improvement, the results at the sentence level are steadily close to the result of human evaluation. Finally, the improved indicators are applied to the passage level. To distinguish a single scene, we split the input passage into several sentences to extract the scene and compare them with the output passage. It can be seen that each step of improvement at the passage level also has an improvement. Finally, as about the Chinese corpus, the Chinese dependency syntactic analysis API was used to assess Chinese extraction. Experiments were conducted at the sentence level, and the result was 80.4%, which is also consistent with the human judgment. This research improves SEMA. There are mainly several aspects. The case of an in less than an out is considered, and the semantic alignment used to reply string matching, mainly based on three aspects: for alignment, partial alignment, and hyponymy alignment. Finally, a semantic retention evaluation measure about TS-SEMA based on semantic alignment is formed. We did experiments on English and Chinese corpus. The result shows that it is similar to the human evaluation result. In future research, we will continue to use larger corpus to explore SEMA's evaluation methods. In addition, the TS indicator proposed in this paper only evaluates the semantic retention. Other aspects of evaluating TS need to be further explored. At the same time, follow-up research should collect multi-subject, multi-genre, and multi-length text to test the usability of our indicator. That's all. Thanks for your listening.